Hello children, in the last class we discussed about the closure property for the whole number, and we have an introduction class to many kind of numbers like whole number, natural numbers, integers and rational numbers, right? So in this class, as you have given the homework that we have to check the closure property for whole numbers, rational numbers and integers, right? And then we'll proceed with some more discussions as well. Okay, first let's look at this. I hope you have tried to do it, and if you have stuck somewhere, then let's understand it now so that your doubt gets clear. Okay, so the first case of whole number. Okay, what are whole numbers? First write out the whole numbers. It starts from 0 and it has all the positive numbers, right? 1 2 3 4 5 and so on. Now let's look at the addition process. So in addition, what happens? You add two numbers, right? 0 plus 1. 0 is a whole number, 1 is a whole number. If you add, it becomes 1. So 1 is also a whole number. Similarly, 0 plus 10. Okay, 10 whole number, right? So that means you can actually figure out all the whole numbers. When you add them, you will get whole numbers only. You will not get any other numbers, right? So that is why we can say again here that whole numbers are closed under addition. Okay, whole numbers. You remember this picture we have shown last time? How do we relate between closed numbers and a closed group of friends, right? So just remember that. Okay, if you have not seen my last video, please go and watch the last video so that the concept is very much clear. Okay, so similarly for subtraction. So if we take subtraction, 10 minus 0 is 0, 5 minus 5 is 0, right? And then any other number, let's say 25 minus 10, 15, 50 minus 3 is 47. So whatever you do here, you have till now you have got whole number minus whole number, you are getting a whole number only, right? But of course when you do, let's say 0 minus 3, what happens? This becomes minus 3, right? So when you say minus 3, this is not a whole number, right? Because this is a negative number, it comes under integers. Yeah, it's a integer, we can say it's a integer, but it is not a whole number. Okay, so we have to say that similarly the whole numbers are not closed under subtraction. Okay, whole numbers are not closed under subtraction. Okay, because when I subtract two numbers, there are cases when I do not get a whole number. Okay, and similar kind of thing we have to do for multiplication and division as well. Okay, so if you look at division now, let's look at multiplication first. So for multiplication of whole numbers, so whole numbers are 0, 1, 2, 3, 4 and so on, right? So let's do the multiplication. Let's say 2 multiplied by 3 is 6. 10 multiplied by 0, it is 0. 0 multiplied by 0, it is 0. Okay, why I am giving a lot of 0 example? Because we have an additional number 0 right here compared to the previous example where we have taken only positive numbers or natural numbers. So that's why since 0 is the addition, I am just trying to do a lot of operation with 0 so that it is clear for you. Okay, so now if you look at whatever two numbers you take, whole numbers, and multiply, you will get another whole number only. Okay, so whole numbers are closed under multiplication actually. Okay, whole numbers are okay. Division, you know, right? Last time also we have taken, if we take the same example, 2 divided by 3, it becomes 2 by 3, right? Or 2 upon 3, and 2 upon 3 is actually a rational number, but it is not a whole number. Okay, so what does that mean? That means that whole numbers are not closed under division. right? Because when we divide two numbers, we're actually not getting another whole number, we're getting another rational number. Yeah, there are cases that where we're getting whole number, but there are also cases where we're not getting whole numbers. So as we have discussed in the last lecture, if for once also the rule is not satisfied, then the rule is not true, right? That's mathematics. Okay, so if it is true means it's always true. Okay, that is how mathematics function. Okay, I hope this is clear, right? So we have discussed about the closure property of the whole number. Okay, then we'll go to the closure property for integers. Okay, it's simple actually, means if you have already got that concept that what we are doing, then it is very simple. Okay, when we say integers, it starts from negative numbers, includes zeros and goes to positive numbers, right? So it has -1, -2, -3, -4, 0, and then it goes to positive numbers also, like 1, 2, 3, 4. All these numbers are included in the integers, right? Now if you do addition, obviously addition will be closed. Okay, because we have seen this before. -1 plus -2, how much it is? -3, right? If the signs are same, then the numbers are added and we put the sign of the number, right? So -1 plus -2 is -3. This is an integer, we add another integer, I get another integer only, right? Let's say negative number and positive number I will add. -4 plus 5. When signs are different, what happens? Subtraction happens, and the number which is higher or bigger, that sign is being put. So here -4 plus 5, so 5 minus 4 I'll write 1, subtraction I will do, and the bigger number or the higher number is 5, so its sign is plus. Okay, so I'm not going to put anything, because plus is like by default when we write a number, if we don't put any sign, it is considered to be a positive number, right? I'm just explaining this process as well. If you have any doubt also, you'll get it clarified. Okay, so now if you look at, this is an integer, this is another integer, if you add we get also integer. So integers are also closed under addition. Integers are, okay, clear? Now if we take the case of subtraction, okay, whole numbers and natural numbers were not closed under subtraction, right? Let's see here what happens. I will subtract -1 minus 0, so it becomes -1. 2 minus 3, it becomes -1. 3 minus 3, it becomes 0. 10 minus 5, it becomes 5. Do you see this? You took a natural number, took an integer and an integer subtraction, you got another integer, because the negative numbers comes under integer only, right? Similarly here also, one positive number, subtraction another positive number, you got a negative number, then also it comes under integers. 3 minus 3, so two integers you have taken and you got 0. 0 is also integer, so in this case also you are getting a integer, right? So that means integers are closed under subtraction. Got it? Clear, right? Till now in all other kind of numbers, the whole numbers or for the natural numbers are never closed under subtraction, right? But integers are closed under subtraction. Okay, clear now? Now let's go to multiplication and division. Okay, so similar case. So here if you go to multiplication, 2 multiplied by 3, 6, minus 2 multiplied by -3 is how much? Also 6, right? Minus 10 multiplied by 4, -40. So here you see, you multiply two integers, you get another integer always, right? Negative numbers also part of integer, correct? 6 multiplied by 0, you get 0, right? So integers are closed under multiplication. Okay, and if you go to division, yeah, again it is pretty much clear, right? Take two numbers, 2 divided by 3, you get 2 by 3, right? So here 2 by 3 is not actually a integer, right? It's a rational number. Here these are not closed under division. Okay, so integers are not closed under division, but integers are closed under multiplication. You got it now, how we are doing it, right? And last case is our rational numbers. Okay, so what are rational numbers? Okay, we know rational numbers includes in positive numbers, negative numbers, zeros, and also the numbers in the form of fractions. Okay, so all numbers will be here with the rational numbers, like we'll have negative numbers, zero, positive numbers, and fractions also. Okay, so all these numbers are part of rational numbers. Now let's do the same thing, addition. Okay, addition will be closed. Okay, under addition rational numbers will be closed. Okay, because anyway we have seen it already and we can visualize now, right? You take any two numbers, let's say 2 divided by 3, it is a fraction which is actually a rational number, plus 3 divided by 4. What happens if you add these two numbers which are actually fractions? You take this as 12, then 4 2s are 8, plus 3 3s are 9. Okay, so 9 plus 8, 17 divided by 12, or 17 upon 12. So this is another fraction, right? So if I add two fractions, I get another fraction only, I'll not get anything else, correct? So in that way we have to say that the rational numbers are closed under addition. Okay, for subtraction also this is the case, because if I take again, let's say I take 3 by 4 minus 3 by 5. Okay, two fractions, correct? 20, 5 3s are 15, 4 3s are 12, which is equal to how much? 12 minus 15 minus 12 is 3 divided by 20, or 3 upon 20. This is again a fraction, right? So why we are not doing about positive numbers, negative numbers, those we have already done, right, as part of our integers. So same result will come. Only difference in this kind of category of rational numbers is fraction. So I am trying to do all operations in terms of fractions, right? So here also in fraction, if you see, either you will get a positive fraction or a negative fraction or 0, right? But all those comes under rational numbers only. So that means we can say that rational numbers are closed under subtraction also. Okay, now coming to multiplication. Simple, right? You can visualize already, I guess. Let's say 3 by 4 multiplied by 0, it is 0. Minus 4 by 5 multiplied by 5 by 9, how much? 5 gets cancelled, and this is minus 4 by 9. Okay, minus 4 by 9 is also a negative fraction, but it is a fraction, so that means this is also a rational number. That means whatever two rational numbers you multiply, you will get another rational number only. Okay, so rational numbers are closed under multiplication also. Okay, now let's come to division. Our rational numbers are closed under division also. It looks to be yes, right? Yeah, it is closed because all fractions are here. So if I take 2 by 3, so this is actually 2 divided by 3 is 2 upon 3, and 2 upon 3 is a fraction, and these numbers are there in our rational number category, right? So you might be thinking that yes, rational numbers are also closed under division, but actually this is not the case. Why? Because do you remember we have done something like this, 2 divided by 0? Remember that? So 2 divided by 0 is 2 by 0, and 2 by 0 is actually undefined. Remember? It is undefined. That means we cannot find it out that how much it will be. Okay, if we cannot find it out, so this is not a number, right? And if it is not a number, it cannot come under rational numbers also, correct? That means there are other cases also, but remember this case, it is straightforward and it will come to your mind. immediately any number when you divide it by 0, you don't know what number it gets. So of course we do not know this number, and this number cannot be part of rational number because we don't know what it is, right? So the division, so rational numbers are not closed under division. Okay, it looks like that it is closed because you immediately, we have taken all fraction examples, so immediately fraction comes to the mind and we say that yeah, fractions are there part of rational number, so it can be closed, right? But it is not, because there are cases when you divide two rational numbers you don't get another rational number, right? I hope this is clear, right? If you have any doubt, I think this is being cleared. Okay, so we will now see these properties in a tabular format so that things are pretty much clear and you get a view in one place. Okay, so now you look at the table. Okay, whatever we have discussed till now is being put into this table. So this is the gist of all our discussion. If you can understand this table clearly, then I think you got the whole concept properly. Okay, so here are natural numbers and here different kind of operations, right? So natural numbers are closed under addition. Natural numbers are not closed under subtraction. Natural numbers are closed under multiplication, and natural numbers are not closed under division. Okay, the simple way to remember this table is that if you see, all the numbers are closed under addition and multiplication, right? That means if you add two numbers, it gives the number of same category. If you multiply two numbers, it gives the number from the same category. Okay, so addition and multiplications, for these operations all kind of numbers are closed. Okay, but none of them are closed under division. Okay, so if you remember these three categories easily, or if you can understand these three categories easily, it is very simple. Under addition, all numbers are closed. Under multiplication, all numbers are closed. Under division, all numbers are not closed. And for subtraction, natural and whole numbers are not closed. Integers and rational numbers are closed. Okay, so this is the only little change here. Otherwise all other columns are quite straightforward. Addition all closed, multiplication all closed, division all not closed. For subtraction, only natural numbers and whole numbers are not closed. Integers and rational numbers are closed. Okay, just go through this table, slowly try to understand it, do practice wherever you feel like some confusion is there, and come back to me with questions. Okay, so we are done with the closure property. I just went in very detailed of this to make sure that you understand when we analyze a particular property for different numbers, how does it look like. Okay, so for next session we are going for associative and commutative properties. Okay, this will be simple on the similar lines and we will discuss this together. Okay, so I hope this is clear. Please practice and put your questions if you have doubt. Thank you.